Hello, my name is Massimiliano D'Arienzo. I am professor of inorganic chemistry at the Department of Materials Science at the University of Milano-Bicocca, of course. And today I would like just to introduce you to the Materials Science and Nanotechnology Masters. That is, let's say, in continuous evolution, since material science, as you know, is something that is very dynamic, especially in these last 10 years. So if I can share the slide, okay, we can go on, I guess. Okay, and I would like to start saying you, okay, what is a material? Because it's the first question that we want to answer whenever we deal with material science. And of course, if you ask to ChatGPT, you can find this answer, any substance with specific properties that make it suitable for a certain use. So one can ask, I am a chemist, so I can ask to myself, which is the difference between a chemical compound and a material? Chemical compound, of course, is an aggregate of atoms and molecules, but when it becomes a material? It becomes a material when it is think for a specific purpose or function. So the same aggregate of atoms and molecules is designed already for a specific target. That's the difference, and that's the real definition of a material. You can go on. And if you think about the history of the humanity, the progress of the humanity was parallel to the progress of the material, starting from the Stone Age to the Iron Age, and then coming to the most recent history. You can find other material that follow line step by step the life of the humanity. You can go on and go on. Okay, and this is the today what we have in this last century, let's say the Silicon Age, the era of the nanotechnology, and most recently the quantum computing and the artificial intelligence. So about, let's say, a few words on the Silicon Age. Transistor is the main important material that we had in the mid of the last century. And if you think the evolution of this material along the years, it goes very far, considering that today more than 6 billion of people use internet, and you can find more than 5 billion, over 105 billion of transistors packed in a small area in the CPU, in the modern CPU. And again, another important, let's say, material is plastic. We have let's say, the last Nobel Prize in chemistry in Italy, Natta, who discovered accidentally, we will say, the polyethylene and then the polypropylene. And this is the basis of everything. And for instance, one of the most used application is tire. Very important in the frame of materials. And again, the era of the nanotechnology and the famous statement of Richard Feynman, and there is plenty of room at the bottom, the era of the nanotechnology that is still growing in everyday life. And more recently, as I said, the artificial intelligence era and the benefit coming from quantum computing. This is something that we are approaching also in our last years in terms of new courses and new possibilities for students here at Material Science Department. So, and another joke I want to tell you, what you see here is a can of Coke, standard can. It's aluminum, manganese, and magnesium. But if you make a simple experiment here, the video is not charged, but okay, we can think about that. We make an experiment, we just put this can inside the soda solution. What you can find that there is an ultra thin plastic film inside the Coca-Cola can that protect this the alloy of aluminum, manganese, and magnesium to the corrosion of Coca-Cola that contains acid. So actually you discover, and this is the message, you discover a material whenever you study really the chemical composition, the structure, and also the interaction of this material with other form of energy or other material. And this is what we do every day here at the Materials Science department. So coming to our core business of today, what is really material science and nanotechnology? It is an interdisciplinary framework of between condensed matter, solid state chemistry, and the touch of engineering, which is, in our view, like a clover, okay, where you put, where you can find the real receipt to understand what is and which are the application for the material. So which are the goals of the master in material science and nanotechnology? Of course, innovation and sustainability. This is something that we cannot avoid in these days. The mission is to design, of course, and create material with new properties and function. And as an instrument, we can utilize, of course, the creativity and improve our skill in knowing how to synthesize, how to apply, and how to characterize these materials. And here I just put several examples of the application and also the field of research that we have in our depth. And as you can see, we span from hydrogen technology to sustainability, solar cells and photovoltaics, nanomedicine, quantum computing and artificial intelligence, catalysis, and also batteries. So many, many things we do together with materials. And another example is our collaboration that we have with Pirelli. This is just 1 kilometer from here. And we are in the let's say, our department was a storage of the tire of Pirelli before that the university came. So with them, we collaborate and we produce tailorable formulation for tires thread. And here you can see an example that was developed actually in our department, in our labs, and now it is a product that is commercialized by Pirelli. And again, another example, material science for sustainability. As I said, and inclusivity, this is an example of a researcher coming from Iran, who developed an idea to capture throughout specific treatment of membranes, water from the fog. I don't know if you know that in Iran there is no water. Of course, it is a lack of water, but also there is this kind of tower that absorb the fog and transform and condense the fog into water. She studied actually suitable membrane in order to enhance this capture and to, in this way, collect water from fog. And this is another example. So coming to the core of our educational program, of course, there are three main field higher education programs: scientific research, technological transfer to industry. And these are concentric in developed by the master in material science and nanotechnology. These are listed in the slide, the learning objectives that of course are very broad, but what I want to focus now a little bit more, there are the 4 possible study tracks and the double degree pathway. So we have a study track on functional material for nanotechnologies, materials for energies, material for digital and quantum technology, and the dual degree in sustainable materials. This dual degree, and also for the master, you can apply if you have a degree in engineering, in chemistry, in physics, and of course in material science. And you can have courses in English. You can share your experience with a lot of international students. The proportion are here listed. You can have the opportunity to complete also your master thesis in another country, and now we will see where. You have a strong mix of experiences from around the world and across diverse fields of knowledge, and you can have a training also in partnership with several companies. And here some detail of the dual degree. that is called SUMA, that is financed by the European Institute of Innovation and Technology, IIT, in which University of Milano-Bicocca is core partner, together the University of Trento, together the University of Grenoble, the Montan-Leuben University, and the QE Leuven. It is an European master degree in sustainable materials. So you have the double degree pathway with dual qualification recognition at the end. On one side, University of Milano-Bicocca, on the other side, KU in materials engineering by KU Leuven. And here you can see some detail, and then I hope that you will have the possibility to share with the people interested in this slide. You can have a first year in which you collect 6 credits related to fundamental and profiling course, and the second year in which you have the specialization courses and the thesis and the internship you can make this internship in different places, and you can choose among these possibilities that are listed here: Trento, Leuven, Grenoble, and Madrid. Moreover, there are other possibilities if you don't apply for the SUMA dual degree to go abroad and to experience, of course, an Erasmus traineeship, or for the thesis on exchange extra UA, also for the master thesis in several countries. And we have already some convention and some exchange with several universities that are listed here. So there are plenty of possibility to go abroad, even if the starting point is Italy and University of Milano. Finally, career and professional opportunities. Here I have listed some of the possible professional opportunities that you can have at the end of the master in the research of development, in the field of energy and sustainability, electronics and semiconductor, industry and manufacturing. Think about it, we have a partnership, for instance, with Pirelli. Every year, Pirelli finance us throughout a consortium called CORIMAP, free grants for PhD, and also several our previous students are now hired and working in Pirelli, and even another good partner that we had for many years was, and still many students are hired by these companies, ST Microelectronics, in the field of electronics and of course semiconductors. So we have plenty of possibilities, especially because Milan is a very active and very, let's say, is the most, I would say, active economic environment of Italy in terms of companies and industrial opportunities. So some number, this is taken by the survey of Alma Laurea, is a famous website where you can find some statistic on the course. And as you can see, we have an employment rate very high, as well as a not bad salary to be the first one in terms of average net monthly income. So here you can find some links and content, of course, the e-learning webpage where you can find more details on the courses, and also also the content of the courses. There is a website of the department, there is the website of SUMA dual degree, and also the email address for any information that you need about the didactic activity of the Master in Materials Science and Nanotechnology. And thank you for your attention. And then